creating a cavity pour mold using DragonSkin 20 NV. In today's video, we're going to show you a step-by-step procedure that we took to create a cavity pour mold using the DragonSkin 20 NV. Now, why do we use that particular material? It has low viscosity when compared to some other silicones, making it ideal for cavity pour molds where a liquid material has to make its way all the way down into a small crevice and to tight places, making sure that it doesn't trap any air bubbles. Now, what are some of the benefits of using a cavity pour mold like this? It uses a lot less material for creating the mold than a block mold would, resulting in huge material cost savings. It still captures all the detail from the original model so that we can reproduce it and cast many reproductions with the same level of accuracy. Furthermore, it's extremely durable and long-lasting for production castings of gypsums, resins, and other casting mediums. Now, one of the downturns of creating a cavity pour mold is that it takes a lot more of labor and time invested to create the actual mold compared to a block mold. Now, let's just jump into this project and see how it's done. Now, to start our project, we first need to protect our model. We know that we're going to be building up clay over the model, so in order to protect it, we're first going to wrap it with some foil or saran wrap in this case. You can use plastics, just some barrier that's going to protect the original model from the clay that we're going to apply over it. Now, I've laid the clay already out in a specific thickness that I want the mold to be in. So all this clay that I'm applying is already at 3/4 of an inch thickness. So I know that when I'm applying this clay, the thickness of the mold in that area is going to be 3/4 of an inch. So you can see I'm filling the entire surface of the model with a layer of already rolled out clay. Now, this is Sculptix oil-based clay, Sculptix Soft that I like to work with, easy to manipulate and is friendly to platinum silicones. Now, here I am building up some channels. Again, I'm cutting up strips of already rolled out clay in order to maintain a certain thickness of all the parts we're building up. Now, these channels here are going to interlock the mold into the support shell once the mold is made and in use, and then also going to help deliver the material into the cavity that we're creating. Now, notice around the bottom there is a raised edge as well. That's going to interlock into the support shell once it's finished. Also, on top of the head, we build up a cylinder. That's going to be the pour spout where we're going to pour the material into. Make sure you make the pour spout big enough so you have space to pour the material and air for space for the air to escape as well out of that mold. So next up, we're going to place shims. These are aluminum shims that I already pre-cut to a certain length and width. And here I'm applying some shims that already have the built-in keys, the V-shaped keys that are all pointing towards they're pointing one way. And then we're going to go around and fill in the in-between area with the rest of the shims. This is where the support shell that we're going to build is going to separate into halves. Now, at the bottom of our working surface, we're going to add some pre-cut keys. These are going to help our support shell align over the original model once we take everything apart. So we're going to build a support shell over all of this. These are again going to help us align the support shell once the shell is finished over the original model, so to say. Now, to make sure that everything releases from the working surface, we're going to put some sonite wax on those wooden keys that we made, and also the working surface itself, which is a melamine board surface. Now also the sonite wax gets applied to the aluminum shims themselves on both sides, just in case we forget which side we're working on. It's always safer to apply it to both ends. Now for the support shell we're using the Plasti-Paste 2. And this is a throwable plastic that is used for support shells. The Plasti-Paste 2 has an easy and convenient mix ratio of 1A to 2B by volume. The working time is 10 minutes, while the setup time or handling time is 90 minutes. And we're going to mix the material thoroughly and then apply it directly to the clay that we laid out. And you want to take good care when spreading the material to be extremely close to the clay. You want to make sure you press the material against the clay so there's minimal voids. The Plasti-Paste 2 has a working time of 10 minutes, and I simply cannot mix large batches of the material and apply it all in one go. So I have to break down the application in multiple smaller batches, which allows me more control over the material. No need to worry about newly mixed Plasti-Paste 2 adhering to previous layers, as the material bonds to itself very well. So I apply it in thin layers, and I usually do 2 to 3 applications to achieve a thickness that is sufficient for the size of the mold that I'm making. For this type of mold, anywhere around half an inch to 5/8 is a good thickness. Keep in mind that the thickness of the edge of your support shell should be the same as somewhere in the middle. The material is now allowed 90 minutes to cure before moving on to the next step. Once the first half of the support shell has cured, we can remove the shims, the aluminum shims, using some pliers. Here I'm helping myself with a knife as well to get those out. And then we're going to apply some more sonite wax just to make sure that everything will release from each other, especially the two halves of the support shell. So make sure that you put a thorough layer of the sonite wax on the support shell, first half of the support shell. We can proceed to making the second half of the support shell, and we're just going to proceed the same way we did on the first by mixing the Plasti-Paste and applying it in several layers over the clay itself. Once the Plasti-Paste is built up to the thickness that we want, we're going to allow it now to cure for 90 minutes before proceeding on to the next step. Now the next step is to clean up some of the edges of the Plasti-Paste that we built up. Some of that is very sharp and we want to clean up the edge. Here I'm using a 4.5-inch grinder with a sanding disc. I like to use this tool because it works fast and it's easy, but you can also use a handheld sander like this one here. It actually works very great when you're cleaning up surfaces, large surfaces, as you see me do right here. But for the edges, I like to use the 4.5-inch grinder. Just make sure that you're always safe, wear eye protection, wear a dust mask, and of course, make sure you know how to use the tools. Next, we're going to drill some holes in the edges of our support shell. These are going to be holes that are going to be holding the bolts to bolt down the two halves of the support shell. All right, and now we're ready to open up our mold. We're back in our workstation, and when you are opening a mold like this, you want to proceed slowly. Don't try to break the mold open in one shot. Work around the perimeter. You can see here how I'm using some mixing sticks and working my way slowly around and prying the mold open, or the support shell open. And here we have the opening, removal of the support shell, and the clay itself comes right off of the model as well. You can see our model is safely protected with the plastic foil that we put over it, and we're able to remove the support shell and the clay in one go. Now the fun starts in removing all that oil-based clay out of the support shell. I'm not going to lie, I don't like doing this, but it's a necessary step. We're going to proceed by scraping the clay out with a mixing stick in this case. It doesn't damage the plasti paste. It's plastic, doesn't have a sharp edge on it, and you can scrape out all that Sculptex and put it in a storage bin because we're going to repurpose that clay for the next cavity pour or next mold that we make. Now the last bits of the oil-based clay are softened up using some isopropyl alcohol and then simply wiped out with a paper rag. This removes most, if not all, of the clay that was in the mold. Now there were some imperfections when we were applying the plasti paste, and little cavities have shown up in the support shell. We can simply fill those with a little bit of the oil-based clay Sculptex. You can use other clays. I like to use the harder one here, Sculptex Hard, just because it stays in place much easier. Now we're going to go around the perimeter and drill some breather holes into the support shell. These holes will give air a chance to escape from the liquid silicone and the cavity and help minimize any air bubble entrapment in the finished rubber mold. So make sure that you place them strategically where air is going to build up inside the mold. Now, because this is a bit of a larger mold, we're going to secure the support shell on the working surface using some screws and washers, and you can see how nicely that all fits over the original model because we had those markers, those orientation markers that we placed on the model to begin with. Now everything gets bolted down. And then I'm going to lay out some oil-based clay, again, Sculptex oil-based clays. This is the soft, around the perimeter of the mold. Wherever the material could leak out of our shell, I'm going to place some oil-based clay. That way we don't have to worry about the material leaking out in areas we don't want it to. As mentioned earlier, we're using the DragonSkin 20 NV for this project. This is a low viscosity silicone rubber. Now it does have a easy and convenient mix ratio of 1A to 1B by volume, but keep in mind it does have a short pot life, a 6-minute working time with a 30-minute cure. So work thoroughly, work fast, and then here you can see we're double mixing. And once we mixed everything thoroughly, make sure you don't delay, pour it immediately into your mold. And here you can see the benefit of having that large opening because we're simply able to pour the material into the mold, and then we're going to plug some of those breather holes as the material starts to fill up the mold. It's very beneficial to have a low viscosity material that flows easily. We're simply able to pour the material into our mold and don't have to worry about the viscosity, the thickness of the material, and the material not making it into the pour spout, or even worse, the material just having too much drag against the model and the support shell, and then being too slow to fill that void, causing a lot of air trapment. So really good benefit here to have a low viscosity material. Now, one final look over the entire mold to make sure there's no leaks that are not wanted. So we want to make sure there's no material coming out before walking away from the mold. Now we can allow the material 30 minutes to cure before moving on to the next step. All right, it's been 30 minutes and we're ready to demold our project. Starting with removing off the bolts all around and also peeling away any of the silicone that has leaked out of the bleeder holes that's stuck onto the support shell. Now, once we remove all the bolts, make sure you remove the screws that are holding the support shell onto the working surface. We don't want to crack that. And then we're going to pry the mold apart, again slowly, because there's a lot of suction on the material. And here you have the first half of our support shell off of the mold. And we're carefully removing the second half. Air, compressed air always helps. And once we remove the mold out of the support shell, we're ready to actually cut the mold open. We planned on cutting the mold open halfway up one of the sides, one of the separation channels that we build up. And here I'm borrowing second set of hands to hold that mold in place. Make sure that they're not pulling on the mold too hard. And then we're going to cut the mold open using a mold knife in a zigzag fashion. So not a straight line, but you can see that it's zigzagging slightly back and forth. Because of the material's low viscosity, we're able to capture all the detail from the original model in our mold, but furthermore, the material is able to naturally degas any of the air bubbles that we mixed into it because of its low viscosity. Unfortunately, our model did not make it. Somewhere in the demolding process, the legs did break, but we do have a mold and we're going to cast many reproductions that are identical to the original. Now, the mold is ready for the casting process, but before we put it back into the support shell, a little bit of talc powder or baby powder on the outside of the mold helps with the alignment and ease of laying the mold into the support shell. It helps the silicone glide over other surfaces, in this case over the plasti paste, into the grooves of the support shell. So once we have that applied, we're also going to apply some sonite wax, especially to the top of the support shell and the side where the mold is cut open. Again, the sonite wax will help with the gliding of the silicone mold into the support shell, but also if there's any leaks in the mold, it will prevent the casting resin or material from sticking to the support shell, which is really important. You don't want to be building up material inside your support shell. And here you can see how easily that mold fits into the support shell, and now we can bolt everything back together and get ready for the casting process. The quarry tone granite fillers are a specialty blend of powders that can be added to some of the smooth cast liquid plastics or liquid rubbers to create stone effects and finish castings. Keep in mind that the material you're casting with should be a fast-setting material so that the filler doesn't settle out to the bottom of your casting. Now, there are 10 different colors for the fillers mimicking different kinds of stone, and depending on which one you choose, they do have large, medium, and small particles. For the casting process, I chose to use the Smoothcast 325 with the quarry tone filler. This will give our casting a stone or quarry type of finish once we have our casting out of the mold. So simply mix and pour the material. Here you can see I'm doing a little tilting motion, making sure any air bubbles that got trapped in the casting get released. And then we're going to top off the mold with the rest of the casting material. The material is then out to cure for 10 minutes before moving on to the next step. All right, we're now ready to demold, and I have already removed the support shell from our mold. And I'm slowly prying the mold out of the support shell, and then we're going to demold our casting. And I'm pretty pleased with the casting itself. The seam line is not visible. There's very minimal flashing around the bottom of the feet. And I can simply jump into finishing the casting with a patina of shoe polish. So a little bit of shoe polish and isopropyl alcohol will give us a nice slurry patina that we can apply over the sculpture, and then wipe any of the excess off with the isopropyl alcohol and a paper towel. As you can see in the close-up shot, the Dragon Skin 20 NV mold has captured all the detail down to some imperfections from the original model. And we can now use this mold to manufacture and cast many reproductions that look absolutely identical to the original. Now, if you got inspired by this project and you would like to give your own mold making and casting projects a go and need to purchase some materials, you can visit any one of our distributors around the world. So, and there you have it, a step-by-step procedure that we use to create a cavity pour mold using the DragonSkin 20 NV, requiring a extremely low viscosity material for a project like this. Now, if you have an idea about what we should do next, please let us know down in the comments below. If you like this video, hit the thumbs up button. To keep up with our latest mold making, casting, and other videos, remember to subscribe.